back to my channel. Today we will discuss on how to write a lab report, and for this video we will discuss on experiment 2B, projectile motion. Okay, so let us start. So first one is you must able to write, okay, the lab report follow the rubrics. Okay, so we should start our report with the title, where experiment 2B, projectile motion. So here you will get 1 mark. Secondly, you must start with the learning outcome. Okay, you must state what is the objective. So the objective is to determine the accelerations due to gravity by using the projectile motion. So you will get another 1 mark. Okay, after that, based on the data given, okay, so you must write as well the uncertainty and also the unit. Okay, so because height we use the ruler to measure, therefore we must write the uncertainty for the ruler is plus minus 0.1 and the unit is cm. And the horizontal length r, also we use the meter rules to do measurement, therefore we must write plus minus 0.1 cm. So you will get 1 mark, 1 mark. Okay, height and also horizontal length here is actually a primary data. Okay, so after we obtain h, r1, r2, r3, of course we must find the average for the horizontal length. So we take r1 plus r2 plus r3, we divided by 3, we will get the average value. And because here the uncertainty is 1 decimal place, therefore our value for our average we also must write in 1 decimal place only. Okay, so we must write 41.7, 49.5, 56.6 and so on. So remember, this one you must write 1 decimal place only. Okay, so if you write correctly, you calculate correctly, you will get 1 marks. Okay, next one, because the questions ask us to plot h versus r squared. H versus r squared. So therefore, after find the r average, what should we do is we must find r squared. R squared is the secondary data where we use calculator to calculate, okay, to get the value, okay, to get the data r squared. Okay, so if you press calculator, 41.7, okay, if we square it up, actually we will get 1738.89. Okay, but remember, for secondary data, we only allow 2 or 3 decimal places only. Okay, so here because 17.838 actually is quite long, so we can write it in a prefix form where we can times 10 to the power of 3. Okay, so therefore 1, 2, 3, so it's much more easier. We write as 1.74 times 10 to the power of 3. Okay, so we can round off, become 1.74. Okay, or if you don't want to write 1.74, you also can write it as 1.739. Okay, also correct because also 3 decimal places, 1, 2, 3. Okay, 1.74 also correct because 2 decimal place. Okay, so if you want to write in 2 decimal places, all must consistently 2 decimal places. Okay, if you want to write 3 decimal places, all must consistently write 3 decimal places. Okay, so this one, if you calculate correctly, you will get another 2 marks. Okay, because this one you must follow the decimal places and you must press calculator correctly. Okay, next one we goes to after complete the table, now we can next step for calculation part, we can find the centroid first before we plot the graph. So centroid again, because we plot h versus r square, so r square is our x-axis, so this is our x-axis, and h is our y-axis. Okay, so x-axis here you just copy down whatever you write at here, 1.74 plus 2.45 plus 3.20. Okay, so you must follow back, you copy down everything, and remember you must also copy down times 10 to the power of 3 because this is not 1.74, this is actually 1740. Okay, so you cannot write 1.74. So after you write everything, you bracket, then you must times 10 to the power of 3. Okay, so remember this one. So if you write, you will get 1 mark. If you didn't write, you will minus 1 mark. Okay, because this is actually not 1.74. This is actually 1.74 times 10 to the power of 3. So it's 1740. Okay, next H also you copy down and then you divide it by 8 because we have 8 reading. Then we will write, find the calculation, we find the average. Okay, find the average, and remember you must also write the unit for R squared, so it's cm squared. Okay, and also here you must also mention 4.25 times 10 to the power of 3 cm squared. And for H is 32.5 cm. Okay, so if you correct this one, substitute all correctly, you will get 1 mark. And the answer, the centroid for x and also y axis, correct value and with the correct unit, you also will get 1 mark. Okay, next we goes to plotting the graph. So when we plotting the graph, okay, we have 11 marks. So again, we must repeat. Okay, how can we get these 11 marks? So the first one, you must write correct title, you'll get 1 mark. And then you must label x and also y axis and with the correct unit. So here you don't need to write okay plus minus, you just label height or h units in cm, so you get 1 mark. And for x axis, okay, I enlarge it a bit. Okay, so here, okay, so for our x axis, okay, x axis also you must write, okay, you must write r squared times 10 to the power of 3 because this one actually is, okay, is in not 6, it's 6,000. So remember you must write r squared times 10 to the power of 3 cm squared. Then you will get another 1 mark. Okay, so next one is you must use the correct or suitable scales. Okay, suitable scales here for x axis or for r square, okay, you can use 1 until 6, 1, 2, 3, 4, 5, 6, and we need to calculate. Okay, we must calculate what is the smallest divisions that we can read here. Okay, the smallest divisions that we can read here, okay, is 1 divided by 10 and half of the smallest scale. The smallest scale is 10, so we must divide it half of the smallest scale, so we divide it by 20. So you press calculator, 1 over 20, you will get 0.05, meaning that later when we substitute the value into x-axis to find r square here, you must write 2 decimal places. Okay, for y-axis again, 5, so 5 over 20 because half of the smallest scale. Okay, so we press calculator, 5 over 20, you will get 0.25. Okay, so 0.25, so it's 1, 2. Here also 2 decimal place. Okay, so it's better here also you write 5.00. Here also 10.00. Okay, so if the scales that you use correct, you will get 1 mark for x-axis, 1 mark for y-axis. Okay, next one is, okay, we go back. Okay, next one is, of course, if you refer to the graph, the next one, the marks that we will get here is actually you must draw your graph. Okay, the size of your graph must at least 60% of the graph paper. Okay, so you will get 1 mark. And then if you draw centroid, okay, centroid you must circle. Okay, you must circle, so you will get another mark for centroid. And then you will get 2 marks for plotting all data correctly. Okay, so here we have 8 data, so all the 8 data that you plot must correctly plotted. Okay, follow the scales. Okay, and then you will get 1 mark for the best fit line. Of course, this best fit line, the first one, okay, you must pass through centroid. Yes, already passed through. Okay, the second condition is you must pass through as many points as possible. Here already 1, 2, 3, 4, 5 points. Okay, so this is we consider it as many points as possible, and also balance on the both sides. Okay, so here at the bottom of the line we have 1. Okay, at the top we have 1. Okay, so balance. Okay, so you get 1 mark for the drawing best fit line. Okay, next one is you must draw 1 mark for a triangle, the gradient of the triangle. So remember, as I mentioned, you must draw at least 50% of the graph. Okay, so usually we will measure 8 cm and 8 cm. Okay, so if you count here already over 1, 2, 3, 4, 5, 6, 7, 8. Okay, already over 8 cm. Okay, if you compare, refer back to x component. Here already over, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one you will get full marks for your graph. Okay, next one. Based on the gradient, the plotting point 0.30 and 5, and here our y2 and x2 and y2 is 6 and also 47.5. Okay, so we go back to the calculation part. Okay, go back to the calculation part, then you substitute here. Okay, so for calculation part, y is 47.50 minus 5.00. Okay, because just now we already know that the smallest division, half of the smallest division is 2 decimal places. So correct. Here we have 2 decimal places. Here also 2 decimal places. If we write 47.5 minus 5 also cannot, because we must read 2 decimal places. So here you must add on 0. Here you must 0.00. Okay, so 1, 2, 1, 2. Okay, for x-axis is our r square. So our r square is 6.40 minus 0.30. So it's 1, 2, 1, 2. And remember, okay, most of the students forgot to write times 10 to the power of 3, because this is not 6.4, it's actually 6,400. And this is not 0.3, actually this is 300. Okay, so remember to write times 10 to the power of 3. Okay, so if substitute correctly, you will get 1 mark, and the answer with the correct unit. Okay, so what is the correct unit? Because our y, the y-axis, h is in cm, and then for r square is cm square. Okay, so cm you cancel off, you will get cm -1 or per cm. Okay, so correct unit, you will get 1 mark. Okay, now we refer back to the significant figure. Okay, how many significant figure can we write? Okay, so for 47.5 here we have 4 decimal place, a significant figure. 5.00 is 3 significant figure. 6.40 is 3 significant figure. And then 0.30 is 2 significant figure. So of course we will take the smallest one, where equals to 2 significant figure. So we follow back 1, 2. Okay, 2 significant figures. So it's correct. 7.0 times 10 to the power of -3 per cm, per cm. So if you all correctly, you will get 1 mark. Okay, so for gradient total, you will get 2 marks for gradient. Okay, next, the uncertainty of the gradient is given. Okay, so you just copy down, then you write 0.6 times 10 to the power -3 per cm. So you will get another mark for your uncertainty. Okay, step 4 is you must compare the equations with the gradient. Okay, so the equations that give is, we know that the equations given is h equals to 7r squared over 10 gt squared. Okay, so if you compare y equals to mx plus c, and then we know that h is y-axis and your r square is x-axis. Okay, finally we know that 7 over 10 gt square actually is our gradient. So we copy down here, our gradient actually equals to 7 over 10 gt square. And our objective, actually, we want to determine the accelerations due to gravity, meaning that we want to find g. Okay, so we will take g as a subject. So g will equal to 7 over 10 mt squared. Okay, mt squared. So we substitute inside 7 over 10. M is the gradient, where our gradient is equals to 7 times 10 to the power of negative 3. So we substitute inside here. Okay, t squared. Okay, so t squared, where can we find our t squared? Okay, so I change color. Okay, this t squared, actually we must find from experiment 2a. Okay, you find from the graph. Okay, you find from there 2a, meaning that the previous experiment, where we must find the height. Okay, is given for the questions. So we want to find when h equals to 83 cm, what is the time taken? Okay, t squared, what is the time taken? So from here, 83 here. So 83, you draw 83. Okay, not so accurate. And then you find the value t squared, where is equals to 0.166 second square. Okay, so 0.166 here, you substitute into your experiment 2b. Okay, you substitute from graph 1. Okay, so this is actually from experiment 2a freeform motion. Okay, so after that, okay, we divide, and then finally we will get 6.02. Okay, so 6.02. So again, if you substitute correctly, you will get 1 mark. And here the unit, because it's 600, okay, 602.41 cm per second square, because just now our value is still in cm per cm. So when you substitute, you convert cm into meter, you will get 6.02 meter per second square. Okay, so if this one you calculate correctly, you will get another 1 mark. Okay, so since just now this is divide, one significant figure, this is 2, so we can write it as 6.0 enough, 6.0. Okay, so we can write it as 6.0 meter per second square enough. Okay, so this one we don't want, just write 6.0 meter per second square. So you substitute inside here, we must find the uncertainty. Okay, so during if let's say based on the home-based experiment, usually we will not ask you to calculate the uncertainty delta m, because usually when doing in the lab, okay, we will ask you to calculate the uncertainty. So because this data given the delta m, so you need to find the delta g as well, because delta m is given. Okay, so delta g equals to delta m over m plus delta t square over t square. Okay, so t square we know that is equals to just now 0.166. Okay, how about delta t square? Okay, delta t square also we must find from experiment 2a. We take half of the smallest division, meaning that 0.04 here. Okay, so 0.04 over 20.002. So here actually it's not 4, it's 0.02. The answer is 0.59 meter per second square. Okay, so again, if you substitute correctly, you'll get 1 mark. And then the final answer, if you calculate correctly, you will get another 1 mark. Okay, the delta G, okay, because he already round off. Okay, so 0.7 over 6. Okay, actually it's 0.6 lah, over 6 times 100%. Okay, so this is actually, when we round off, it will come 0.6 okay, meter per second square. So this one is 0.6 times 100%. 0.6 over 6, you will get 10%. So this is actually 10%. The percentage of difference between the experimental value and also theoretical value. So we take theory minus experiment with modulus, because we only want the differences between the theory and experiment, over theory times 100%. Okay, so finally we will get 38.84%. So finally we will write our answer G plus minus delta G. Remember, our uncertainty usually only allow one significant figure. Okay, so 0.66, we only want one significant figure, so it becomes 0.7. Okay, so 0.7, only one significant figure, and here only one decimal place. So our result also must one decimal place. Okay, so for discussion part, first one, you report your result. Theoretical value, the experimental value, okay, is a 6. Percentage of uncertainty, okay, percentage of difference between the experimental value and theoretical value is 38.84%. Okay, so actually experimental value, we should write this one. This is actually our experimental value. Okay, so here you must write this one, errors. So again, errors because of the parallax error. Okay, so the second one is because of the air resistance. And then the precaution step, usually we will base on the errors. So if we say parallax error, so therefore what is the precaution step must taken? Meaning that our eye level must be perpendicular to the scales of the meter rules. And the second precaution step is you must switch off the fan during the experiment. Conclusion, you just report whatever value that you found. Okay, so here you must report the theoretical value. Okay, the experimental value, we just report this one, experimental value. So this is actually experimental value, 6.0 plus minus 0.7 meter per second square, and the percentage of difference, percentage of uncertainty. So therefore, the accelerations due to gravity can be determined by using the projectile motion. Okay, so that's all for today. So we'll go to the next video for experiment 3. Okay, thank you for watching. Have a nice day. Bye.